Hi, for this question, it's called high and low. You basically roll a fair 100-sided die with values 1 to 100 on the sides and observe the value that appears. You now must guess whether the second row will be at least as large as the first row or not. If the second value appears is y and you guess correctly, you receive that payout. Otherwise, you receive nothing. Assuming optimal play, find the smallest integer t at which we guess the second row is lower than the first. So intuitively, we know, okay, if we're trying to guess lower, then it must have meant that the number was kind of very big for us to kind of guess the lower half, since the lower half payout is like less than the higher side payout, so it will be kind of skewed a bit over in that side. So the idea behind this is that if we don't care if we're guessing lower or higher at that point, then it would be like the equivalent balance choice where we don't care about which one it is. So it would be equal. So we're just gonna let x be the value of our first row. So if we guess higher, so that would mean y is greater than or equal to x. That means that we can get any number from x to 100. So that means that there is 100 minus x plus 1 winning numbers. So the probability of that would be just that number, 101 minus x, divided by 100 since there's 100 numbers. So our expected payout of that would just be the average of the winning numbers. So the expected value of this would just be 101 minus x divided by 100 times x plus 100 divided by 2, right? So that means that if we multiply these together, this would be our expression over here. And then we have a second choice where we were guessing lower. And this should be the same probability or greater because we would be more inclined to choose that. So when y is smaller than x, we have numbers from 1 to x minus 1. That means that the probability would be x minus 1 divided by 100. The average payout of the winning numbers would just be the sum of 1 plus x minus 1 divided by 2. So that's x divided by 2. So this would be the expected value of that if it's lower. And yeah, the smallest when it's that, it happens when it's this. So setting it up. Basically, you can set it to even to equal at this point because it's the smallest integer. So when we're just solving this inequality, we get something like this, which means when we solve the equation, it's around 71.5-ish. So that means that our next guess would be 72 would be the best number. I think essentially this kind of question boils down into kind of just calculating for the expected value of the payout. And we know that, okay, if we're trying to find the lowest number that could satisfy that we want to pick for low, then it means that at this point we would be neutral. We would be either be willing to pick high or low at this point. So then it should be roughly equal. And if it's equal, we just calculate the expected value of getting low, which is just all the numbers lower. And then if it's high, then it's all the numbers higher. And then just set that in equality or inequality in the sense, and then just solve for that.